do you need anything else for the presentation? The flip chart thingy or?
No.
Okay, cool.
Thank you.
Right now it's VGA, so yeah, let's see the auto switches over. Digital PC client signal, digital PC. You don't have to switch on to do external display, do you?
Maybe.
It may be that this box is not bidirectional, so it's only HDMI out and not in.
Okay, then I'll just use this.
Yeah, unfortunately.
Okay. Can I mirror this? That's a good question. I'm guessing it's like one of these. There you go.
Oh.
I don't know what that means. Double it? Is that mirror? Or is that?
Doppelt is yeah. Cool. Maybe that was not it.
Whatever.
Let's try the duplicate. Which one was that?
This one? Okay.
Yeah, it's
What about that one?
that means only projector.
Only projector.
That one is disconnect, and that one says duplicate, so I guess that's what we want.
What does this say? What does that mean?
Not ideal resolution.
Okay, so maybe we change the resolution.
Maybe this is just the resolution.
I don't know, but can you change the resolution on here maybe?
Yeah.
Try it. 1280 by 1024. Oh, it's
Ooh,
this.
it worked.
Okay, good enough.
Good enough.
Yep. Thank you.
Yeah, keep in mind that you have 25 minutes, starting in 4 minutes, and then you have to stop 5 minutes before the next person starts.
Okay.
Great. And do you want me to hold up the signs when?
Sure.
Okay. I don't know if people are sitting there.
Which one?
I think either one is fine as long as you switch it.
Oh, it's right on.
Hello?
Should I start?
Yeah, let's start in 1 minute.
Okay. Hello, hello, hello. Does it work? Hello? Okay, there we go. Okay, so I'm going to talk about Wikidata Integrator. I'm going to give a couple slides and then a demo bot, and I'm going to try to run through it pretty quickly so we can leave a lot of time for questions. So I'm part of the GeneWiki project, and we built this bot, or this tool specifically for loading biomedical related data, but we've tried to make it as general as possible so you can use it for anything you want. I don't know if I need this slide exactly, but this is a sort of a general overview of what is a bot and what does Wikidata Integrator do and how does it fit. So really briefly, if you have data, you have to write some resource-specific code or your bot to get the data, clean, format it, map it to Wikidata, and then use Wikidata Integrator to take that map data, put it into Wikidata, and lots of other things.
So,
Yeah.
where is your data coming from?
My data, or from many different sources. So in biomedical space, it may come from lots of different specific databases. It could come from CSVs or JSON or an API or an OWL file or anything.
Okay.
Or you could create it yourself. So as an example, so the example that I'm going to go through, we have data from the NCBI, so we have organisms with tax IDs, and GenBank has specific assembly IDs, and we want to load these into Wikidata, so we can actually just download this as a CSV, as a table. We're going to write some resource-specific bot code and then load it into Wikidata using the API. Yeah, so what WDI can do, we can create, edit, delete statements on items, including references to qualifiers. It has some features so that we can check for unique.
Switch mics because this one is not
Going in
working
now.
on and off.
Hello.
Yeah.
It can check for unique identifiers. The really cool feature is fast run mode, which I'll talk about, and some other things, which I'll go into. So it's broken up into four main parts: login, core, fast run, and helpers. So to log in, you can just log in with your username and password, or you can actually use OAuth as well. So you can use WDI in any web-based tools that you want. So this is actually being used in Fatima, which Thomas just walked in. So this is how Fatima is actually writing all of these journal articles. You can authorize through OAuth. WDI core is the main entry point into creating statements. So we have functions that allow you to create any one of the 11 different data types. And I'm going to go through an example in more detail after these slides. So what is fast run mode? Basically, if you're reading something from Wikidata, each API query takes about a quarter of a second, and if you're actually making a write, it takes about a second or maybe faster to perform each edit. So if you have 10,000 items that you want to write, and you're actually doing 10,000 writes, it may take you about 3 hours. But if no writes are required, just to check, all 10,000 items to see if anything is required, it'll still take about 42 minutes, which is not too bad, but in the biomedical space, we have about 1 million items that we're writing or checking. So just to read all 1 million items, just to see if any write is required, that takes about 3 days. So in fast run mode, instead of checking each item individually, it basically makes Sparkle queries on initialization to gather all of the data about each item. And then WDI can check and see if any writes are required, and if nothing is required, then it doesn't need to do anything. And so if no writes are required, it might take about 10 seconds or however long the Sparkle queries take. And we also have a bunch of helpers, so you can execute arbitrary Sparkle queries. We have built-in logging, so after the end of each bot run, it will generate a log file for you. You can search, merge items, tools for creating journal articles, database releases, so you can create, for example, let's try this one. So you can create a release item that you can link to references. We also have ID mappers tools. So for example, you can quickly retrieve a Python dictionary that contains the gene IDs for all genes in Wikidata, that's P351, and you can filter it by found in taxon human. So you can quickly just write this instead of writing a Sparkle query. Yeah. Okay, so I'm going to go to demo. Anybody have any questions so far? Okay. So the data source that I'm going to use again is a table from GenBank. So it's really simple. We have organisms and tax IDs. A lot of these organisms and the NCBI tax IDs are already in Wikidata. However, the assembly information is not. And as a side note, the assembly is interesting because it can link us to information about the bacteria's habitat and more information that's on recorded by GenBank. So the first step basically is we download the data, and so that's here, and I'll show the pre-processing in a second. We do a bunch of imports that we need. So from Wikidata Integrator, we can import WDI core, login helpers, and property store, which I'll talk about in a second. I like doing this in all of my bots because it makes the code a lot easier to read if we can have names of the properties instead of referring to them by their PIDs. So I just use these because it's nicer, and the same thing with the items as well. This is just some pandas code for loading and pre-processing the data. And this is basically what we're going to use. So it's a list of a tax ID to an assembly ID. And all we want to do is look up the Wikidata item for the organism that has this tax ID, and we want to create a new statement that contains this GenBank assembly ID. Okay? So another feature that's in WDI is, okay, I'm just not going to use this, is core properties. So the way a core property works is if we're adding a statement using one of these core properties, WDI will check to make sure that this identifier is unique across all of Wikidata. And if not, it will throw an error, and we can decide what to do with it if we catch that error. So we can define, so a lot of the biomedical properties are already defined in WDI, but if you have one that you want to add yourself, you can just add it in the WDI property store. So we just GenBank is not in here because this was a new property that just got added a couple weeks ago. And so we're just going to add that GenBank is a core ID. And so if we try to add a statement on an item with a GenBank ID and another item already has that ID, it'll throw an error. So this is just some uniqueness checking that it'll do for you for free.
So it's not an identifier that you're using of the GenBank? I just didn't follow that, sorry.
So yeah, let me show you. So here's the Wikidata page for this organism. It has a NCBI taxonomy ID here, and then we are adding this GenBank assembly ID here.
So you are adding an identifier?
Yeah.
Okay.
Yes.
So, one question, sorry. So what is the, so I may have missed the beginning of the session. What is the bot aiming to do exactly?
The bot is aiming to, so we have a table, which I don't have on, I had it set up on my computer, but there's no HDMI, so I'm using this. We have taxonomy IDs from a resource, GenBank, linked to the assembly IDs, and the assembly IDs before this bot were not in Wikidata. So the bot is going to add these statements on items, and it's going to look them up based on their taxonomy ID.
And where is the bot retrieving data from?
GenBank. So it gets it from, let me see if I can pull up the table. It gets it from here. A table that looks like this. When you download the table, it actually contains the information. It's not showing it here. I don't know.
And if the relationship would be more complex, like having to create another page, would the bot be able to do that in an easy manner as well?
Yeah.
Excellent.
And qualifiers, which is good.
Yes. I mean, we've used this bot to do everything in the GeneWiki project. This example is purposely simple, so I could get through it in 15 minutes. Okay, so we log in here. I also want to set up logging. So we have a feature so we can add a header to a log. I like doing this so I can keep track of each of the bot runs, and I'll show you what that does at the end. Created a function here to create the references. So I'll show you, whoops. So what the references that I want to add look like. I want to add stated in GenBank, retrieved on a certain day, and add a reference URL. So the way I can construct that in WDI is I create a statement. So WDI core item ID, the value, and the property. So the value is this GenBank item that I had defined up at the top. The PID stated in, and I'm saying that this line here is a reference. Same thing with the time, so I'm going to add a time statement. This is just the Python date time object, retrieved, same thing, and then I create a WD URL statement with the reference URL property. And this function takes in the GenBank ID, which gets put in right here in creating the reference URL. Where the shift? And then it returns a list of statements. And then this is our reference that we're going to pass in to create the larger statement. How am I doing on time?
12 minutes left.
Question?
Yeah, I was wondering whether you were also contemplating doing this from the wiki itself, like with a special page, or do
Say that
you-
again?
With a can you do this similar thing like from the wiki itself with a special page, or is the intention just to keep this separate from the wiki?
Sorry, I'm not understanding. To
So
do this from the
whenever you
what?
are uploading new contents to the wiki,
Yeah.
you may, I don't know, if you don't have like only the ID, but you have a whole CSV, maybe you don't want to use a bot for that. You want to use it from the wiki itself, like you upload a CSV and a whole lot of new pages are created. Are you contemplating that kind of?
That would be
use case?
nice. Does a tool like that exist?
Quick statements.
There are tools that are being called labs with web interface, not a phone. Maybe you
Yeah.
refer to that.
That would be nice.
Well, I know that in MediaWiki there are like special pages where you can tweak to import this kind of thing, but I don't know if you guys were thinking about that.
Yeah, the issue, so with those tools and with quick statements, it's hard to make references and qualifiers, especially if the reference is not the exact same reference for everyone. So if you want to add identifiers in the reference. Also, what's cool about this and what we really use it for is the fast run mode. So we can just run on a schedule and keep things up to date from an external source, which is also, you can do that with quick statements, but you don't get the benefit of the fast run and you have to automate it yourself. Okay, I'm gonna skip some stuff and you can check it out on your own. I just want to show you how the statement is actually created. So that's basically this line right here. So the GenBank statement is a external ID. We give it to the GenBank ID. It has the property, the GenBank assembly accession, and then we can pass it a list of references. So each statement can have a list of references. So this is going to be a list of length 1 that contains the reference that we created using the function that I just showed you. So once we have this GenBank statement, then in order to actually do the write, we create item engine instance, and we can give it a list of statements that we want to add to an item. In this case, there's just one statement, so there's just a list of length 1 that contains this GenBank statement. We can give it the item ID. The way that we figured out the QID of this item is through, so we have this helper function that retrieves the taxonomy IDs. So we have ID mapper, give it the NCBI taxonomy ID property, and so this returns a Python dictionary where the key is the NCBI taxonomy ID, and the value is the QID for that item. So we're just looking it up in this dictionary, so we can pull out this QID. And we turn on fast run mode. And one more thing that we have to do for fast run mode is we have to tell it, we have to give it a filter that lets WDI know what types of items that we're going to be adding, so we can do that initial query and figure out the initial state of all of the items. So we give it a filter that says all items with a GenBank assembly number. So what this is going to do is it does a Sparkle query and gets all the information about all items that have a GenBank assembly accession. So that way when we do fast run mode, it already has the information about all of these items stored locally, and so it can determine whether or not a write needs to take place. And there's another helper function, try write. So what this does is it tries to actually perform the write in Wikidata, and it will automatically catch errors for you and log them into a log file, and if it does the write successfully, it'll log that as well. And so when you run it, it will dump out this log file for you. So you have a header, whatever, this is anything that you want to put in. It just prints it on the first line, comment it. We can log warnings, so if we had data that we could not find in Wikidata, or there were duplicates or something, we can log that as warnings. This is just using the Python logging levels, so info, warning, or error. And yeah, so print out this log file. And then I have additional code for handling references in a special manner. So for example, let's say we want to run this bot every week, right? Because we want to, there's new bacterial genomes created, and the assemblies may get updated on GenBank every week. But there's 1,000 items, and we don't really want to go and update this retrieve date every week because it's just spam edits for no reason, just to update this retrieve date. So let's say we only want to update the retrieve date every year if nothing changes. So what we can do is we can write a special function in here. So that I've called this update retrieved if new. And what that does is it checks the retrieve date, and if the retrieve date is less than a year old and nothing has changed, it just skips it and doesn't do anything. However, if a year has passed since we've updated the retrieve date and still the value hasn't changed, it updates the retrieve date. So you can encode any special functionality that you want in this. And that's basically what this cell does, and I'm not going to go through it, so we have time for questions.
Question, please?
Yeah. I think she was first. You're first.
That's fine.
Okay.
Just a question, because this is for the pharmaceutical products, right? Using this database to get the information. My question would be, if you want
Genes,
to...
not pharma. Genes.
Which are you looking at?
Okay, I opened the link that was on the wiki page, but maybe, okay, yes, this is for this.
I may have had another
Gene,
demo
right?
in there.
Yeah.
Can you maybe touch the cable again, because it says just been tinted.
I may have stepped in.
Thanks, better.
My question would be, if you want to take another source of data, how difficult would it be to modify the code? Or how easy?
Depends on the input. If
Like,
you're,
this is the first question. The database of the source must be very similar to the format you showed us?
Not really, I use it for politicians.
Yeah, so there's basically, I guess there's really two parts to any bot code. There's the code that takes the data from wherever you get it from and reformats it in an easy to use manner. And then there's the part of the bot that constructs the statements from the data. So if you've written the bot code that constructs statements for one set of data, and you want to then apply that to another source of data, you would really just have to write the code to parse wherever you get that data from into a similar manner as before. Is that sort of?
Thanks.
So my question is about whether or not your bot then follows up. So do you keep somehow track of all the Wikidata items that the bot is editing and making sure there are no, I don't know, that someone doesn't change something and...
What we do with GeneWiki is, so for example, let's say we're updating all diseases or something.
Yeah.
The bot gets run on a schedule, so it gets run every time there's a new disease ontology release or every month. And so if somebody has removed something that was we put in that was from a disease database, it will just add that back. If they've added a new statement, it shouldn't overwrite it. It doesn't overwrite it, it just will add a new statement along with it, so a new value.
So, okay, I'm trying to think of something I think I talked about with Doc James. We're monitoring, let's say, medicine of sorts, and if we have a statement with the specific amount or dosage, he wants a way to follow up on people not changing the dosage easily.
Mm-hmm.
So, yeah, I was wondering if it could do that.
Yeah.
But,
Yes.
okay.
Yeah, first, thanks for developing the tool. It's been really helpful for what I've done so far. And my question is, what are the plans of their further developments? Is it now kind of finished for you, or do you have specific plans?
So yes and no. So it's on GitHub and we accept pull requests. There has been talk about sort of reformatting it in a way to what was mentioned before, in some sort of way where we can put the data that we want in a spreadsheet and then build WDI rules for how to construct Wikidata statements out of that data in a much more user-friendly manner, so you don't have to like write up the Python code. You can actually just create a rule and apply that rule to a column in a spreadsheet, and that data could use data from other columns in the spreadsheet. That it's just an idea right now and hasn't really been even attempted. So it's,
someone showed yesterday a tool that does, I think, what you're talking about, of taking, let's say, CSV and then converting it easily, automatically, so then you can copy paste it into quick statements, so it does all the legwork, kind of, with references and qualifiers and like rows of data.
What
so
tool?
it's, I don't remember the name, it's CSV to quick statements, I think something like that. I can
That's
find
the
it.
name.
Yeah, that's the
CSV
name.
to quick statement.
okay.
So it kind of cleans up your CSV and
Okay.
lets you just copy paste to the two quick statements, and it does exactly what you just mentioned, I think.
Okay.
Unless you have
I
other
don't know. I'll look into
hidden
it.
agendas that
No,
I'm
I'll
not
look
sure
into it.
about.
Okay, thank you very much.
Thank you.
Time is up, unfortunately. Next session here is about Wikidata CLI. Thank you very much.
Which? This one? Yeah. Yeah, so it's running, I can show you where we have it running.
Can you do kind of Vigi?
That should be easy. Okay, yeah, that's it.
We have, I'll show you on.
Just code on the screen.
You want me to wait with the time sheets and it's 15, 5 and
All you
a
need
minute,
to
or
do
just
is
just 10 minutes remaining and 5?
That is
I
actually
don't have a 10-minute
one
sheet.
box, and then
So want me to hold up
that you get
15 minutes, 10 minutes? No, that would be
So you
I'll
don't,
try
you
to do
could
this.
literally just run the whole notebook.
Thanks.
Redirect to the notebook.
Yeah, you already had another talk, right? So I don't have to remind you.
Oh yeah, that's an
5
old
minutes,
one.
starting in 1 minute. And
Yeah.
then
Yeah, that one I thought was too confusing, so I changed it. If you go back to the submission page. Oh, okay. Awesome.
Yeah.
Yeah.
Are you here at lunchtime?
Yeah, I'm here till Wednesday.
Oh, perfect. Well, I'm not. I just have a few more hours. But I think lunch is 1:30. Can we meet in the area and talk?
The cafeteria?
Yeah, that'd be awesome.
Okay.
See you later.
Oh, I see. Yeah, it's like right there. Yeah, I put two. I'm sorry. Yeah. So that right there just downloads the data. So it's just in that text file right there.
Yes.
switch to one of the on.
So it's not that long.
Hi everyone. Who is here for the Wikidata online interface demo? Okay, good. Is it okay if I speak without the mic, or do you need the mic? Okay, so I will just talk loud, right? So I can have the hand on the keyboard. So just to know a bit, who already used it, this tool? One person? And all the others, 2 person? Okay. And who is not familiar with command line tools at all? Okay, so that's good. We can go forward. Okay, so wikidata-cli is a command line tool I wrote on top of 2 libraries that I presented yesterday, which are Wikidata SDK, so JavaScript libraries, Wikidata SDK for read operation, and Wikidata edits for write operations. And I put them in 2 different repos because the write operations requires authentications, and so it's, well, it was a nice separation. And so all the commands in command line interface are basically wrapped up of those libraries. And I suggest we go a bit through the documentation and see what the command has to offer. So the documentation is split between the read operations and the write operations, and the config. Maybe we should start by saying a few words on the configuration, because so you don't need any configuration if you just want read operations, but you will need configuration for write operations to set up username and password to get your tokens. And there is a feature request for OAuth authentication, so that you don't need to put your username and password. And that's we get to work on it, and it's coming. But you can upvote the feature request if you think it's really urgent. And out of that, yeah, configuration is mostly about persisting options, like do you want it to be always verbose, or do you want the result to always be copied to your clipboard, these kind of things. And read operations. So search, that's one of the last and one of those I use the most now. It's basically, is it big enough? Yes. Maybe I can go. Okay. So, well, if it's big enough, let's continue. So sorry, for every command, yeah, if you run it without arguments, you get a small help menu, at the exception of one. We'll come to that one later. So search is about finding entities by text. So let's say I want to find Wikidatacon entities. I get an ID, a label, and a description. And if I want it to be in a different language, so I will use the lang option, and for short it's just L. And let's say I want it in French. I can have, here it's just the descriptions that will be different, but you get the ID. And so that's really convenient when you just want to know, find what you want to work with. Yeah, just more context on how I came to develop this tool. I'm working on this project named Integrator, which is about doing inventories of books with on top of Wikidata, data on books and authors. And so we are all the time jungling with Wikidata identifiers and things you want to know what they look like. So often you might just want to find what is Victor Hugo's number, and then or anything like that. So that's kind of tools is search is quite convenient often. And you also have a JSON flag. So if you want the results to be formatted as JSON, so that it's not working. Okay, it should work on other comments, not that one. So that was search. Okay, Wikidata label is basically when you know what you want, the entity you're dealing with. When you have basically all real operations are do you have an ID and want some data about it, or do you have some data and you want an ID? This one is about when you have a data and you want to know the label. So it's just Wikidata label and the ID. And all the commands have an alias, shorter version, so WDL will be for label. And the same, you will find all those aliases if you enter the WT alone, you get all the documentation with the aliases just after the pipe. So Wikidata label, Q1, so it's universe. The same can be done for description. So totality of space and all matter. And you can also do with the, it's just, sometimes as the aliases try to be just one letter, there are some collisions, so you got to be careful. Like Wikidata description and data start both by D. So for description, it's actually, maybe it doesn't have an alias, but okay. So label, description, claims. So what are the claims of Q1? And so claims is when you want to have basic understanding of what is in this entity. So here you can say, give me the claims of Q1, and then filter by property, just the P18 properties. And if it happened to, I will click forward. Yeah, I use the option to, so in configuration, I use the option to have always, when possible, the result copied in my clipboard, because then I can copy it when I want, where I want it, but we can disable it for the demo, because it can be confusing. So, okay, so we know that for Q1, the claims are those, maybe. Yes, we can have the JSON version of this. But this is for a human reader. Like that's a way to just understand what is happening about this QID. But often you might want to have the raw data about an entity. So you can, there is the data command that just gives, it's just giving you the result of the API for this identifier. And then you can give it, as it's JSON, you can give it to JSON parsers. You might know GQ, which does things. but for Wikidata, I developed a small one that is JSON div that you might find there, and that takes an argument for the how much div you want to see on the JSON object. So by default, it shows 0 div, but let's say we want 1, and you get already like one more level logged to your terminal, and yeah, that was needed because otherwise your terminal is just bloated with all those data. And you can also walk a bit the tree, so you can pass arguments GT claims 18, and then just, well, show me 3 levels, and we should see, yeah, pretty much all of it. So it's often convenient when you want really custom behaviors from raw data, and just, yeah, for instance, you can also do something like, well, this tool has its own interfaces that could be developed, but that's not the subject here. So, keys, yeah, all sorts of things. But so back on those claims, coords. Well, that's a small alias, just to get coordinates of QID. Data, we just saw that one, and working with GT. Or you can also get multiple, an array of an array of entities directly from the API. And oh yeah, so in the Wikidata SDK library, there is a function to simplify claims, because by default, claims look like this. Yes. So that's the wrap version, but if we give all the claims look like this, and often you just want the direct value. You don't want all those details, so you can pass the simplify flag to get the direct value and, well, just what you need when you don't need to access qualifiers, etc. We have more there. Revisions is a bit experimental, maybe. Yeah, someone requested a way to access raw data about revisions on a given entity, but it's not, well, it's still experimental, that one. This one is for when you have data and you look for the associated QID, and it relies on site links, like it will try to find what is there an article in the Wikipedia from your language that has New Delhi as the title and gives you the corresponding ID. So yeah, going from one direction to the other, things like that. Oh, I use it a lot actually in this way. Like, you are somewhere on Wikimedia projects, you have a URL and you want the ID associated with it. And you're lazy to look for the Wikidata item link on the link. You just pass it to WD ID and you get the identifier. And that's where it's useful to actually ask for it to be copied to your clipboard, because then you can just give me the Wikimedia ID and then I put the ID where I wanted to put it. Okay, this one is quite nice. That's the one command that, when passed without arguments, doesn't show the help. You have to explicitly ask for the help menu to show the help menu, because by default, WD props dumps you all the properties with their labels in your language, and you can even ask for types of those properties, so you know if it's an external ID, a quantity, things like that. And you can request it also as all those commands in your language. So let's say Netherlands. And what happens is that I don't have a local version of the Netherlands, because this dump is taken from, is basically a Sparkle query the results of a Sparkle query to get all the properties and the labels in the requested language. And so it keeps a cached version because you don't want to do a Sparkle request every time you want to know the properties. So I didn't add the Dutch version, so it made the Sparkle query and returned it. And since a few days, you now have also the possibility to pass it a string to which it will filter the properties. So if you just want the properties that have something to do with images, you can just pass some string. And well, that's basically like a graph, a case-insensitive graph on the properties to have an idea of what is around. Is it going too fast, too slow? Okay, Sparkle. So WD Sparkle is a command to run Sparkle queries from your terminal. So I prepared a small Sparkle query there. So I have a .rq file with a very basic query. So select the works from Stefan's deck, and thank you. And so I can just pass it as an argument, and I get all those IDs parsed. And I should probably have some options there. Yeah, I can request the row output. But yeah, most of the time, just having this is nice. Maybe it works in JSON. Yes, you can have the result as valid JSON, and it's missing in the documentation. You can also do simple triple queries, like when you well, the query we just did actually. The query we just did could have been done this way. That is that we have this WD query command that accepts that generates basic triple queries. So I know the property, I want P50, and I know I think it takes the syntax of subject, predicate, object. So I have to pass an object, and here it was what did I say about? Sveg is this ID, and yeah. So for basic queries, you can do this way. Well, you have a few options like limits. Oh, labels. Yes, that's a nice one, because that's a bit raw, and it didn't work. Okay, that's a bit. WD Open is the laziness add-on. Like when it's too much effort to go on Wikidata entity queue this, you can just. Oh yes, I recommend this. All your systems should have this kind of clipboard navigator, because then you just put things in your clipboard. It's really
like a password.
Yeah. Sorry?
Like your password when you show it to
someone.
someone.
Passwords, QIDs, credit card numbers, everything. It's very safe. But basically, I have this ID in my clipboard, and I just want to see the Wikidata page, so I can WD open it, and it shows me the page directly. And it also takes a P flag for Wikipedia, because W was taken for something else. I can't remember. And it opens the Wikipedia page in my language. So let's say I switch to French, I can see the Wikipedia page in French. Okay, and that was all for read operations, I think, yes. So now we have a few minutes for writing operations. So basically you have the possibility to set label, description, aliases, claims, references from the command line. So we can see an example. Well, let's use the sandbox. So you can set a label on the sandbox in French. So let's just go there first. So the sandbox, for those who don't know it, is this item where you can do your experiments. And so it's nice for when you want to train a bit for the command line. And so we want to change this label to something else. Say that it's Bulgro's sandbox. And so, yeah, the syntax is just the ID, the language, the value, and then waiting a bit. And then you get, so the API response as valid JSON, so if you want to reparse it for some reasons. And now that should show up there, yay, that's ours. And so as all those comments, it takes aliases, so it's SL. And now we can say Wikidatacon. Yeah, you get the idea. So the same is valid for descriptions. Aliases are have a few different commands because there are several aliases. You set the label, but you can add aliases or set aliases. Like they are different because there are several of them. But it's pretty much the same behavior. Adding claims, so we can say that the sandbox as P2002, so Twitter username of Bulgos, and the same, you get the response, yes. And that's nice sometimes from the command line to be able to do that, but it's also very nice to be able to do this in bulk in scripts. Like I tend to write scripts where I have 100 of those commands aligned, and like especially in text editor where you can just put a lot of those in line. Like, if you say you have a CSV and you can just like convert it manually to something like edit it in your CSV and then make it execute it from your environment and add all the claims with your credentials like this. And I find it more reliable than quick statements because you can tell it to tell you when it fails. Done. And so when it fails, it tells you, and then you can restart where you wanted or do modifications. And so when you add a claim, you get an identifier like this. And so you could get it actually like this. And claim ID equals this. Yes, the claim already exists. It tells you when you re-add a claim that already exists. And so now we have the claim ID as a variable, and we could add reference to the claim ID. And, well, okay, the interface will change on this one because the properties for references were hard-coded to just use import from and reference URL, and we'll make it dynamic so that you can use this tool on other Wikibase instances. But at the moment, it could be just, so I imported it from the Wikipedia, which Wikipedia? Norwegian Wikipedia. It's the sandbox, so we can say anything. And yay, that works. Okay, so that's pretty much all of those. And oh yeah, there is this one also that is nice. It's update claim. So when you have a value and you just want to update it, so it's like wrapping several commands. It's finding the value, finding the claim ID, and replacing it by the new claim ID. And that can be convenience. But I'm not sure I have the time to show you that because I wanted just a minute to show you what is now possible since today at 1 a.m., which is the possibility to create entities from the command line. So here I have data from books that are in Inventor but not yet in Wikidata, as we use the same, well, it was looking like this. So that's how it comes out of the Inventor API, but if you clean it a bit, you get something that is ready for the Wikidata API. So removing the specifics of Inventor. Removing the prefixes, because we use prefixes in Inventor. Okay, so now we have this file, and we can just wd create item and passing it the 637. Yeah, so our JSON file, and import it to Wikidata. So now it's there, we should see it. Yeah, so it's imported, La Crise de Trop, a book by Frédéric Lordon, and we might want to specify that it's imported from, so our area for add reference, this is imported from Inventor, .io server, let's say, and oh yes. Ah, yeah, we will have to specify on all the statements. Well, this needs a bit of work still to be like to create the item and add all the references at once, but you get the idea. Be careful with the reference identifiers in shell, because there is a $ at the middle, so you want to use single quotes so it's not interpreted as a shell thing. And now that should okay, this needs still some work, but yeah, you get the idea. Thank you.
Thank you very much. Fortunately, there's not so much time left for questions because the next session will start in 4 minutes, and it's about interlinking OpenStreetMap and Integrator.
Okay. If you have questions, you can just come to me at any time. And also, we have a meetup tomorrow around Inventor. So it will be at the Wikimedia Deutschland office in Berlin. And we can talk about Inventor, but you can also come for questions around the JavaScript tools.
Okay.
Is that just the next session here ready? Arun Ganesh?
Also click wieder.
You need a more recent version because
Very much like
Maps session? Maps?
Maps.
Yeah, maps.
No, no.
Actually, they use lists in the Netherlands. They use lists in the Netherlands and they document them in Wikidata. So we can do that. They call it serial ordinal, serious ordinal, and then they use the number on the list and the affiliation, parliamentary group, but they don't have states. So we could just annotate them, right?
Maps.
Yeah, maps. Visuals. I'm in the right session.
Thank you. So this is the Maps workshop. I'm pretty excited to do this. So a little about myself. My name is Arun Ganesh. I go by the name user Playmat on both Wikipedia and OpenStreetMap. My sort of background is I've been interested in maps for quite a while. And I got started creating maps for Wikipedia. Let's see if we can just find them quickly. Yeah, so essentially many maps like that, what you saw. And also one of, this was a featured map from 10 years ago. So I started creating maps on Wikipedia around 10 years back in 2005 or 2006. These were all done in SVG and also helped create a lot of the cartographic standards for Wikipedia at that time. And very soon realized it was a pain to make maps like this on graphic software. And each time there was a change or there was an error, everything had to be updated on Wikipedia. And that's when I learned about OpenStreetMap project and got involved a little more over there. And since then I've been highly active on the OpenStreetMap project and looking at ways how we can bring the maps from OSM back into Wikipedia to have maps like this back again on Wikipedia, which is scalable, highly updated and accurate. And the amazing thing is there's been a lot of technical developments on MediaWiki software, on OSM side with Wikidata, and all of these projects are coming together.
as we speak right now, practically in the last few months, and it opens up a wide range of possibilities of what can be done now, and what's missing is making these systems easy for everyone to use. Not everyone knows what can be done, how these projects connect, and that's what this workshop is going to be about, to show what these different pieces are, how it connects together, and how these maps can finally be created on MediaWiki's projects. So the workshop items, I guess everyone has the Etherpad link. What I've done is I've put in quite a bit of notes on this particular wiki page. So if you can open this. I think a lot of the base documentation is here, and anything else we can keep adding to the Etherpad link as we go along. To start off, how many here have edited OpenStreetMap? Okay, that's amazing. So many of you already have basic knowledge of how this works. The next part, so I'm not going to introduce maybe OpenStreetMap. Wikimedia Maps, everyone knows about that as well? No? So the Wikimedia Map Service, I think is a year old. Maybe someone from the foundation can correct me if I'm wrong. But essentially it's a tile server hosted on the WMF infrastructure, which is a clone of the OSM data with a custom style on top. The URL for this is maps.wikimedia.org. And all this data is from OpenStreetMap. I'm not sure of how updated this is.
Could you repeat that URL slowly, please?
Yeah. Maps.wikimedia.org.
Thank you.
I should have it here, yeah. So this is the Wikimedia Map style service, and this is an alternative to using the OpenStreetMap tiles directly. You have tiles right on the Wikimedia WMF infrastructure, which is synced with OSM. Does anyone know how often these maps are updated with OpenStreetMap? I'm guessing it should be a week, but it could be lesser. So essentially, if you're finding data which is missing or something to improve, all you have to do is edit OpenStreetMap, and these maps should be updated maximum within a week. So let's maybe talk a little bit about OpenStreetMap. The OpenStreetMap project started in 2005. Is there anyone here who's been editing OSM since before 2010? So everyone's pretty new on OpenStreetMap. Wow, okay. It started in 2005 as a very geeky project to let's use the concept of Wikipedia, but for map data. So let's all collaboratively map the whole world. And that's what the OpenStreetMap project is. And if there's anyone here who doesn't have an account yet, I do urge you to sign up so we can maybe do some simple edits on OSM. So everyone can have a hands-on experience doing that, how easy it is. And then we'll keep going one after the other. So the OSM project is a crowdsourced map of the whole world. And essentially within a matter of minutes, you can edit any part of the world with full freedom. There's no moderation of any sort. You find a missing road, a missing building, a wrong street name, you can update it and save it, and it's live right there. At the end of 12 years, at the end of, since 2005, the map has grown tremendously. Let me see if we can show you what it used to look like and what it looks like now. This service shows a comparison between how OSM was in 2007 and now. And you can see the project started off in London, and it was a very Europe-centric project, with the rest of the world pretty much empty. And I remember in 2007 when I first heard about OSM and I came to the project and went to my hometown, and it was the whole country was blank, there was nothing there. And started adding the first roads in my hometown there. So the roads you see here were one of the first few roads added in India by me. And over the course of the last 12 years, so many people have heard about OSM, and especially in the last 2 years, the project has really taken off. Mainly because the editing interface for OSM has become much simpler. And also more people have become aware of a project called OpenStreetMap. It's still relatively lesser known outside of the technical and open source circles. This is this is in India. You can see what it was, and over the course of 12 years, what kind of data you can collect. So essentially what's happened is the structure of the data model of OpenStreetMap is very freeform. It allows you to draw different types of shapes, points, lines, areas, and then allows you to add properties to them, which are called tags, which are key value pairs, much like Wikidata statements to objects. And contributors have been adding everything from the usual things like roads or restaurants to trees, trash cans, speed breakers, and I don't know, there's so many things which one would wonder if it should even be on a map. Okay, so maybe let's do a little bit of editing. The OpenStreetMap editor is called ID. So what I'm going to do is, let's go to the map. This is the OpenStreetMap website. It's openstreetmap.org. And it looks fairly simple. You can do a search. And right now it just looks like a map. Nothing really special about this. But once you click on any of the results, you start seeing what it means to see the OSM data. So right now we are on a data page for this particular object, which is a node for Berlin. This is the last change that happened. So someone corrected the name tag for Arabic. This is the user who changed it. This is how many times it's been changed, 119 times. This is the commit ID. And these are all the properties for this particular point. And you can see this is in a way like what we see in Wikidata. It's a whole set of statements. Say capital yes, elevation is 35 meters, the name of this object, so Berlin in a whole bunch of languages. And a few identifiers. And this is called the primary tag, so this defines what this particular object is, which is in the category of a place, it's a city. And clicking on any of these would give you the wiki documentation of that particular key or value pair or how it's used to map. And also interesting here, the last is you have a Wikidata property, which links to Wikidata. And now this becomes very interesting that you can add these connections between one database in the OpenStreetMap database and the Wikidata database. Also, objects can be part of other objects. In this case, this node is part of a larger object called Germany as the administrative center. So this is like a quick overview of the kind of data structure of objects in OpenStreetMap. It's just another way to explore this data is this is where we are right now. So on the right side, under the layers panel, you can choose a different skin for the map. And here the interesting thing is this little checkbox called map data. And once you click on this, you see all the actual objects on OSM here. And each of this is interactive, and you get the same thing. If you click on any object, you see the properties of the object, who changed it, and all the other metadata associated with it. Okay, so that's the basic of OSM. Let's see what it means to edit OpenStreetMap. Much like Wikipedia, on top you have an edit button, a history button, and we'll just click edit. And this is the interactive map editor on OpenStreetMap. It looks really cluttered. This is, I think, very common in Germany. Germany has one of the most active OpenStreetMap communities in the world. And most of Germany is mapped to such insane amounts of detail with the various levels of objects. And you can see for this particular place, this is being marked as a point with different types of properties. So on the top is, this is the property editor, which is a simple form to add the name, the address, the hours of operation. And what happens is all this essentially gets converted to key value pair list. So this is just like a simple UI to add these key value pairs. And you can even add key value pairs directly over here. So let's add something really simple. Suppose there is a tree at this location and you want to add a tree. The first thing you do is choose the correct type of shape. Tree would be a point. You just click, you've added a point. And then you choose what this particular object is. I'm going to say tree. And it gives you a nice form which helps you decide common properties of it. Everything here is optional. If you do not know of it, you don't need to add it. You can also see how the UI works. So once you choose a property, it gets added as a key value pair. And each of these key value pairs have their own documentation from the wiki on how it works. So it's a really simple to use interface with which you can map any kind of geographic feature into the OSM database. So this is great. This is how you can create map features, and there's already millions of map features available. So how do you use this and get the data out and do something else with it? Does anyone have any questions about OSM at this point? Does anyone want to see how to map something in particular? Or should we do like a live demo or something?
One question: how multilingual is it now? You could see Berlin in many other languages. How high detail is that? If I click on street, would I see it also in another language? I don't think so, right?
That's right. So it's mostly cities and towns, places which have many translations. But usually for other features like streets, you would not really see any other name apart from the local name. There is a way to add it, so you can choose a new language and you can type it and it gets added. But as you can see, this is a highly tedious process and nobody would actually be translating every single street name in a city, unless there's a good reason to do so. And something like this, you would find it for multilingual places. So maybe in Belgium or Switzerland, you would have streets with the different translations.
Street maybe was the wrong example, like some stations or important places could be even more appropriate.
Right. But usually the community in OSM is not that diverse in terms of languages to add so many translations. So unlike in Wikipedia, in OSM it's mainly local people who map a local place, so they would not be knowing the translations and they would not be adding it. And this is where Wikidata becomes really interesting, because Wikidata is amazing for all the translations and the multilingual labels. And having a link from here to Wikidata allows one to bring all those translations to make a multilingual map. Okay, and to complete the saving process, once you make your changes, you hit save, which creates a summary of what your changes is, allows you to write a commit message, and then you just hit upload, and this gets pushed live into the database. In this case, I'm not going to save. I'm going to cancel. Okay, so this is about OpenStreetMap. Anyone have any other doubts on OpenStreetMap, how it works, anything that we want to see? Alright, so essentially we have covered the data structure. Essentially in OSM everything is a geometry and some metadata, key value pairs. And you can also add Wikidata tags, like what we saw. There is a useful tool called Tag Info, which allows one to see all the different types of metadata used on OSM. And like for instance, if we want some stats on the Wikidata tag, we can search for Wikidata tag. And it shows how many objects on OSM have these Wikidata tags. There's roughly 500,000 objects, which are points with this tag, around 100,000 line or area features with this tag. And this is the visualization of the global distribution of objects on OSM with a Wikidata identifier. Okay, so let's see how to connect these two databases. Clearly, OSM is a great place for storing geographic data. Wikidata does not really allow one to do that. It can only store points, but it's not the best place to store linear features and areas and maybe the boundary of a country. But then OSM already has these features in them. And one of the best ways to connect the two databases is to add the Wikidata IDs to the OpenStreetMap objects. And how this helps is this allows one to query OpenStreetMap features based on a Wikidata ID. You can say in OSM, give me the map feature which has this QID, and it will give back the shape for that. This is really helpful. And in the other way around, it helps OSM get metadata from Wikidata and append it on the OSM features. So like the multilingual labels. The other way around, so adding the OpenStreetMap IDs to Wikidata. Now this is not usually done. And the reason for this is OSM IDs change pretty often. So let's take the case of, this is a unique ID for this particular point in OpenStreetMap. And this would be fairly stable, but in the case of a smaller feature like a railway station, yeah, so suppose this railway station is currently mapped as a point, and in future somebody could map it in more detail and make it as an area, which shows the outline of the railway station. And as the shape changes, the ID changes. So it's very common for IDs in OSM to keep changing, which is why they're not considered stable to be added onto Wikidata. But then there's one object in OSM called relation. So we know what points are, we know what lines and areas are, but relations are a special type. Yeah, so this is a relation. A relation is essentially a group of features, group of individual shapes grouped together as a relation with its own set of tags. So this is the relation for Berlin, which is the outline of Berlin along with the central point. And this has its own set of tags, which was different from what we saw for only that point. And this relation is essentially consists of the point Berlin and a whole lot of other lines which make up that boundary. And that boundary could be shared with another relation or neighboring boundary. So these are pretty complicated shapes, and these do not change. So relation IDs are fairly stable. And there is a property in Wikidata, P402, which allows one to add a OSM relation ID to any Wikidata item. And the other thing that can be done is adding OpenStreetMap tags to Wikidata. This is essentially something like, in OpenStreetMap you would define a place as place equals state or place equals city. And this tag can be added to a Wikidata item which defines the concept of what is a city or what is a state. And how this helps is you can now, if you do this, you can start querying Wikidata with OSM tags. And we'll just see this example. So I've written a short post about that. Okay, what this query does is it queries all Wikidata items which have the OSM tag place city, and then lists it according to the population and country. So this is an interesting linkage where you're using OpenStreetMap definitions to query Wikidata items. And here you can see all the cities from Wikidata, ordered by descending population on Wikidata. And using this you can start also seeing probably mistakes in Wikidata where things are wrongly classified as a city. Where over here you might see, I saw something which was a district. But this has interesting quality QA uses for Wikidata.
small question.
Yeah.
Do you have historical, like we have Berlin, which is historical east and west or so? Can you have that also in OpenStreetMap, or is it outside the scope?
Not really. So the philosophy of OSM in mapping is if you see it on the ground, you map it. And that caused a big problem for those who were interested in historical data, that they said this is also super useful information and we would like to have it on OpenStreetMap. But the community decided that this OSM is not the place for historical data because it's hard to verify. You can't go there and actually verify somebody else's work, which created a fork project called the Open Historical Map. And that's the place to have historical map data. But the whole API and the infrastructure is a clone of OSM. Okay, so that's a whole bunch of basics on linking the two. Now let's actually get to creating maps. And the biggest new thing which helps create OSM maps on Wikimedia projects right now is an extension in MediaWiki called the Cartographer Extension. And this allows taking the Wikimedia Map Service, querying an external database, and creating a map very quickly and embedding it in a wiki page. So this is the MediaWiki documentation for the Cartographer extension. Only the Wiki Voyage project has used all the features of Cartographer. I don't think Cartographer is enabled on many of the other Wikipedias or wiki projects. So these examples would not work over there. If you want to try it out, you can do it on the MediaWiki. Go to your username on MediaWiki, create a sandbox or your user page. You can try it out there, or you can do it on Wiki Voyage. And these examples should work. So let's see what the Cartographer extension can do. And this is a simple example. This is a map of Alaska with the map highlighted. You click on it, you get a fully interactive map. And the code to do that is was this. So how the Cartographer extension works is it allows querying OpenStreetMap database using a Wikidata identifier. So what you see here is in the settings, all you do is you mention which is the QID you want to highlight. And Q797 is the QID of Alaska. And what Cartographer does is it queries the Wikidata database to find which of the features in the database has the Wikidata tag for Q797. It fetches that shape and overlays it on the map. And the result is a map like this. There's two basic ways in how the Cartographer extension can be used. You can either use it using map frame or map link tag. A map frame tag will essentially create an embedded frame for the map. A map link tag would create a URL like this, where you click on it and then it pops up the map. And the main settings for the Cartographer extension is the type parameter. You can see it here. So this is how to create a simple map with a feature type. So a feature type essentially allows you to specify the actual geometry that you want to show. So it says put a point at this latitude, longitude. So this is a GeoJSON. And you need to know the latitude, longitude to be able to have this marker plotted here. This in no way queries Wikidata or anything. It just uses the base Wikimedia maps. And it knows this is the point at which you need to put a marker, and it adds it there. So this is the feature type. But if you want to utilize OpenStreetMap and the Wikidata IDs, we use the external data. And this is the example that I had shown. So instead of specifying the GeoJSON feature, you say external data. And then based on the type of object you want, the service is either GeoShape if it's a area, or it's a GeoLine if it's a line. And then you mention the Wikidata ID that you want to query, and that's it. You have this. This is something which otherwise, creating a map like this of Alaska was a very tedious process. You had to find an existing map, trace over it, get all the shape, and then export it to a SVG or export to a PNG and then upload it, and then you would have this. And you can see how easy the Cartographer extension makes this. This is just the starting, so this is just for one QID. What the Cartographer extension also allows is writing a full Sparkle query. And this takes things to a whole new level. What this does is it queries for all the states in the United States. And when you click on it, it fetches who is the governor or the senator from the state. And all of this is driven through Wikidata. The coloring is based on the party. And this is a more complex example where to create an end map like this. The other way to fetch external data is from Wikimedia Commons. Wikimedia Commons has a way to create a page with map data. So the data in Wikimedia Commons is in the data namespace, and how it works is you paste a GeoJSON data here, and you create a data map which Commons automatically visualizes for you. And the Cartographer extension can query that by just using the service as page. So this really is the basics of what Cartographer extension can do. And it's pretty powerful because it also allows you to have like a hybrid querying. You can use some external data, some GeoJSON data specified here. And create a composite map of different things. You can also do styling of features, put colors, choose the marker, shape, marker icons. This is an example of a map of interstate highway in the US, where all you need to do is give the QID of the interstate, and it gets it from Wikidata. So it gets it from OpenStreetMap using the Wikidata ID. Okay, and a whole bunch of examples. Right, so this essentially covers like a full walkthrough of how you can get maps onto wiki pages. What we can do now is we can either try creating maps for something you have in mind, and we can actually see how to put them together using the extension, using OSM, and create something which you always want to do.
So, a side question would be for me, does it support search in any shape or form?
No.
Spatial search?
No. No. There's no map search features integrated as of now. See, we have had one user in India who has been trying different examples. This is interesting. So this is a map of all the districts in India. There's a few missing because the shape was damaged on OpenStreetMap. Either that or the Wikidata ID was not added. You know, the political constituencies in India, districts of a certain state. Rivers in India, this is incomplete. Yeah, but there's various types of examples which Naveen here has done. I don't know of others who have experimented too much with the extension to create these maps. But if anyone has Catalan Wikipedia, is there a URL that you can add to the Etherpad?
Sorry?
Can you add a URL to the Etherpad and we can
Add a link in Etherpad.
Yeah.
I think Russian Wikipedia is using this as well.
Yeah. Finish on the Norwegian ones.
if there are good examples, it would be great to have them
I will.
documented.
I would almost like to show, because our Wikilogs monuments lists are done with list area lists that use cartographer maps.
Oh, wow. Okay.
So yeah, I'll add it there.
And French Wikipedia.
Wiki Voyage has a lot of maps using, they are the biggest users of Cartographer. And they have a lot of practical examples. This is a really useful way. Before, maps like this for different cities had to be created manually. And now the extension makes it really simple to make these kind of district maps to show different regions in a city. Yeah, so at this point, any other questions on the extension itself or on Wikidata, OSM, linking, how anything works, or should we jump into trying out some mapping? Okay, anyone have ideas for maps that they wanted to make for your page or for a certain category?
Can you create a map that I can use for tagging items?
Tagging what?
The latitude, longitude.
Tagging?
So I have a park in the city, and I have all the trees. So I have a park in the city, and I have a list of all the trees in the park, but I don't have the latitude, longitude. I'd like to link a location in the park to a tree in the list. And add the tree to the map as well, as a symbol. As a circle or...
Yeah, the first question is, so there's a lot of trees you want on the map. And the first thing is, where should this data of the tree locations be going? And I think the obvious place for it is the OpenStreetMap project. And your first step would be to map these trees on the OpenStreetMap project. And we've already seen how to add a tree to OSM. So let's look at, once you map the trees on OSM, how would you create that map? Because each tree is not going to have a QID or a Wikidata ID. And you're not going to be able to query it to, for Cartographer to plot the points. So how the workflow here would go is, you'll essentially need to generate a GeoJSON of points from OpenStreetMap and then use Cartographer to embed the GeoJSON data of the points. So the first step is mapping it on OpenStreetMap. And you need to use the satellite imagery to figure out where each of those trees are.
I already have an SVG file.
Okay. Okay, from SVG getting into OpenStreetMap is not easy because SVG has no coordinate information.
And not even as an overlay.
You can get it as an overlay. So this is an interesting use case. And there's a tool called Map Whopper made by NYPL. So what Map Whopper does is it takes an image or a map without any coordinate location and allows you to overlay it on an actual map and georeference it. Let me add this to the Etherpad.
I don't know, it would be great if, there's a version in Wikimedia Labs for the map whopper.
Oh, I had no idea.
Yeah, so it's linked from every map on Wikimedia Commons. So there's map template with a button to bring it to the local whopper.
Okay, how does one access this?
Yeah, just if you go to Wikimedia Commons and go to any map page or a file which is a map, and if it's not marked as a map, then one would have to change the template into a map template. Usually it just happens, is the only thing that's usually needed is only to change the tag information into a map. So that's usually works, and that brings up the button then. So if you go to the source and change information, the word information to.
Is there an easy way to find a map? Okay, so that's the way. Does it work similar to the...
Sorry?
Does the common swapper work similar to...
It works online, yeah.
Yeah. So at least the concept I can show. What happens is you upload an image and you georeference it. Okay, this is not being georeferenced. Yeah, I think many of these haven't been georeferenced. Yeah, but essentially the process is adding control points between your map, SVG, and then an actual map. And the software does the rest for you to figure out where it fits in. Like this. And this can be used as an overlay in OpenStreetMap. And let's see. I'm sure even the common swapper would be giving you a URL like this.
Yes.
Yeah. And this can be brought into OSM. In the background settings, there's a way to specify what background you want. And there's a custom background, which you can switch with what you get from the wobble.
So what kind of format was that? And the picture was a JPEG or?
This, it was an image format, so you can do TIFF, PNG, and you can use this as a reference to start mapping on top.
Yeah.
Yeah.
Very good.
And once you do that, your next step is to extract that data in a coordinate format. And the best way to do that is using a tool called Overpass Turbo. I've added it here. So what Overpass Turbo does is, this is a tool to do querying on OpenStreetMap data. So live querying, and then you can export the data. And the way to do querying in OSM, so this is the Sparkle or query engine equivalent for OSM. And this particular query essentially, don't ask me which language is it, they invented their own language. They're fans. And this queries for any node, way, or relation with a particular Wikidata ID. So what you would want for trees is once you map them. Let's look for a spot with trees. Sure. The easy way is this wizard tool. You can type in a common word here like tree. And this will query OSM for all objects which are trees and give it you, this is, they have done some detailed mapping of trees in this case. And you can export from here as a GeoJSON. And this GeoJSON you can embed in a cartographer map using the feature type, or you can create a commons page. Just like this. And actually, let's do that right now. I'm going to create a new page. Okay, so it looks like I just need to paste the GeoJSON here. I'm going to try that really quickly to see if it works.
Oh, there's a limit.
Oh, wow.
No one can say 2 megabytes.
It's, yeah.
This is what they mentioned, that there's a maximum size for the blob, right?
Yeah.
Okay, that's an interesting limitation. I had no idea. But yeah, you don't want so many trees on the map there. Yeah, so this is clearly a lot of data to add.
Or you can just import a few.
Yeah.
Just delete half of.
Can you edit the JSON text and delete some part of it only?
It's probably the easiest, yeah.
Oh, you can download a new one.
try to the focus coordinate.
Yeah.
This is
Yeah, that needs to be reset. Let's see where this is.
and the zoom level.
Yeah, there you have it. There's some more customization you need to do if you want the markers, like a tree or anything. But then, yeah, there you have your potential tree map that you can embed anywhere.
Okay, so the timetable session is officially up. Since there's nothing happening in this room afterwards, we can stay for questions. But yeah, just so you know.
Yeah. Yeah, happy to take more questions, or if you want to hack on some more examples into the documentation. Yeah.
Just to wait for a mic, or shall I just shout? Just a quick observation rather than a question. It's possible to tag things in Wikidata that don't have a one-to-one relationship, sorry, in OpenStreetMap, that don't have a one-to-one relationship in an OpenStreetMap object. So if you have a statue of Queen Victoria of England, you can say subject : Wikidata equals, and then use the QID for Queen Victoria. And for the same statue, you could have artist : Wikidata equals, and the QID for the sculptor. So that's sometimes a useful thing to do as well if you're adding items to OpenStreetMap or updating them.
That's super useful. If there is some documentation of how to do this, or maybe a small write-up, Andy, could you just add it?
It's already, I already added it to the Etherpad. It's the OpenStreetMap page about Wikidata, and then it links to all the other options for using Wikidata and OpenStreetMap.
Awesome. Thank you. Yeah, one of the biggest issues with using this, all of this is, there's many moving parts in the system. And for those who have been purely into Wikimedia projects, it hasn't been clear how the whole thing works. And the documentation hasn't been easy enough for everyone to start using this anymore. My one goal was to put everything together in one place, so that from start to finish, one knows all the moving pieces and how it fits together. I hope this was useful, and I hope some of us here can take it forward, maybe translate it, improve it, and find a better place for this kind of documentation or tutorial, so that it's easy for the various use cases, like this particular tree map. How to use a map popper, OSM. So there's no simple one solution for many of the use cases. You would need to know different tools and how to take data between them. And we just need much better documentation of how it works. Yeah.
Is there a way that you can show a map of objects that have been associated with Wikidata, and ideally objects that haven't been yet, to see what can be worked on?
You could do that in Overpass,
right,
which is the Sparkle query. Sorry, I'm answering your question. It's the Sparkle query for OpenStreetMap.
That's what's on the screen.
So what you asked for?
That's my house. You're looking at where I live.
This is one. I think one of the examples maybe was added by you. So what you're looking for is you want to see all the objects in OSM which have a Wikidata tag. So like data is equals star. So just show me any feature which has a Wikidata property.
But you could also write a query to say, for instance, give me all the churches that don't have a Wikidata item.
Right. So here is the features which do have Wikidata property, and everything else does not. So you're potentially missing a tag. But then not all of them probably would have a Wikidata ID, like all these buildings. But something like what Andy mentioned, so all the railway stations which do not have a Wikidata ID. So maybe that's useful. So what we want is railway equals station. Sure how to do a not. Andy, would you know how to do?
No, I need to go away and look it up. But I know it's doable.
So this works for railway station and has a Wikidata. For does not might just be.
Thomas, are you familiar with the warper?
Yeah.
The map warper? The tool, the map warper? Are you familiar with that tool? Mapwarper.net.
So these are the only railway stations which don't have a Wikidata ID.
Ich kenne es auch nicht. Also ich versuche es nicht gerade.
But it looks like most of them are already linked.
It's near where I live. Thank you.
Okay, so maybe you can have a look at my little project here. So I opened the map warper, yeah? I uploaded the file, document, and it's here, right?
Right.
It's online.
Yeah.
So these are all the trees. And
Oh wow. Yeah.
so now that's a picture, right?
Yeah.
So how do I geocode that now?
You need to do rectify.
Rectify, okay.
You would get your map and
Map of the world.